Let's look at some examples of converting polar equations into their equivalent rectangular form. As we've seen already, the four equations that we can use to transform this, would be x equals r cosine theta, y equals r sine of theta, r squared is equal to x squared plus y squared, and then tangent of theta is equal to y over x. Usually we're going to use the first three, the cosine, the sine, and then our squared equations. Sometimes the tangent one will pop up, but again, usually it's those first three that we're going to use. So what we should observe first with all four of these examples is if there is a cosine theta or a sine theta expression within the equation, in order to convert cosine and sine to an x and a y, I need to also have an r with it. So I need it to be r cosine of theta to make it an x. I can't just say cosine of theta is x. Okay. So anytime I see a cosine and a sine, I need to think, how can I put an r with it? Okay. And how we do that just depends on the actual equation. So let's look at a few here and we'll see how it goes. So our first one is we have r is equal to 6 divided by the quantity 2 cosine theta minus 3 sine of theta. So this one might look kind of confusing at first. We don't like fractions sometimes, but it's actually not that hard. Okay. How do you get rid of a fraction? You multiply both sides of the equation by the denominator. So if I multiply this 2 cosine of theta minus 3 sine of theta, I can multiply it to the left side. That means I'm going to have r times the quantity 2 cosine theta minus 3 sine theta equal to now just a 6. Okay, the 6 is by itself. And so hopefully now you can kind of see the next couple steps ahead here. We can go ahead and take the r and distribute it through the parentheses. And when you do that, remember multiplication is commutative. So it doesn't matter the order that we multiply things. It's commutative and associative. So when I take this r times 2 cosine of theta, I could write it as r times 2 cosine of theta, right? And that's what we're doing. But remember, the order of multiplication doesn't matter. So I could instead write that as 2r cosine of theta. It's just, I'm just putting the r with the cosine. So again, the order doesn't matter. And we could do the same thing with the 3 sine. So r times 3 sine of theta, I could write as 3r sine of theta, and that's equal to 6. So we have 2r cosine theta minus 3r sine theta is equal to 6. And so hopefully now you can see we have the r cosine and we have the r sine. We can replace those with x and y. And so I'm going to have 2x minus 3y is equal to 6. And for now, I'll just leave that there. That is converted to a rectangular equation. If I really wanted to, we could try and solve it for y, but it doesn't matter. We don't need to do that right now. That's just an algebra process. All right, for our second one, we have r is equal to 4 cosine of theta. All right, so again, we see a cosine, which means I need to have an r with it. Because in order to convert cosine to x, it needs to be r times cosine. And I also see I have an r by itself on the left side of the equation. Well, I don't have, none of the equations that I have for converting deals with just r. It's always r paired with something else, r with a cosine, r with a sine, or it's an r squared. So I need to figure out how to make that r into an r squared. Okay, well, I can kind of take care of both of those needs at the same time, right? I need an extra r with the r by itself, and I need an extra r with the cosine. So what happens if I just take both sides of this equation and multiply by an r? On the left side, r times r is going to be r squared. And on the right side, 4 times r cosine of theta. Okay, so just by multiplying both sides by r, it allows me to take both of the expressions that I'm given and convert them into something that matches the identities or the conversion equations I have. So this r squared equals 4r cosine theta. I can replace the r squared with x squared plus y squared. And on the right side, I could replace the r cosine theta with an x. So I'd have 4x. So x squared plus y squared is equal to 4x. You can leave it there. That's fine. You could also, sometimes you might see textbooks or other resources set that equal to 0. So x squared plus y squared minus 4x is equal to 0. I would be okay with the x squared plus y squared equals 4x. They're the same equation. It doesn't really matter too much. But so just different ways that you might see that. All right, the third one. This time we have r is equal to 3 minus 3 sine of theta. All right, this one's going to get a little tougher. Again, we see we have an r by itself, so that means we need to convert it to an r squared. And there's two ways we can do that. One is by multiplying both sides by r. The other option is we could square it. Okay, and we're actually going to do both here, but we'll hold on to that for a sec. We also have this sine theta. So in order to convert the sine theta, I need it to have an r. So just because of that sine theta, I know I need to multiply both sides of this equation by r. On the left side, we have r times r, which is going to be r squared. On the right side, we have 3 minus 3 sine theta, and we have to multiply that entire expression times r. So that means we have to distribute the r to both terms. So on the right side, we're going to have 3r minus 3r sine theta. And so we've made a good step here. We see that we have this r squared and we have this r sine of theta. Those both match up to some of the conversion equations that we have over here. And so we can go ahead and convert those. We know r squared is x squared plus y squared. The 3r, I don't have a conversion for r, so we're going to leave that as just 3r minus, and I can replace the r sine of theta with y, so minus 3y. So I have x squared plus y squared is equal to 3r minus 3y. Now, we have converted some of this equation into rectangular, but not all of it, because we still have an r. So to be in rectangular, it has to have only x's and y's, no r's and thetas. Okay, so how do we take care of that remaining r? Well, again, the only two options are we can either multiply it by another r to make it r squared, or we could square it. You'd square both sides of the equation, right? So if we multiplied everything by r, that would give me x squared r plus y squared r is equal to 3r squared minus 3yr. Well, notice that turned that 3r into 3r squared, which is great. We have an r squared now. But it also inserted several other r's, and we don't know how to do anything with those r's. So this is not the way we want to go, because we just took one r and made it 3 r's now. So we want to try something different. So instead of multiplying by r, let's think about squaring the r to make it r squared. But to do that, you have to square both sides of the equation. And before we do that, let's isolate the term with the r. Okay, so I'm going to take the minus 3y and add it to the left side. So I'm going to have the equation x squared plus y squared plus 3y, and that's equal to 3r. Okay, The reason we want to do that is if I were to square it without moving the 3y over, I'm going to see the same kind of thing happen that we just saw. I'm going to have an r squared, but I'm also going to have an extra r term in there. So by isolating the r term, when I square it, I don't get this extra r floating around in there. So now let's go ahead and square both sides. So on the left side, we have x squared plus y squared plus 3y. Quantity, all of that is being squared. And I'm just going to leave it like that. I'm not going to bother simplifying that at all. So x squared plus y squared plus 3y, that entire quantity being squared. And then on the right side, I have a 3r, that's quantity is being squared. So 3 squared is 9, and r is going to be r squared. Okay. And so I have the x squared plus y squared plus 3y, quantity squared, is equal to 9r squared. And now that I have this r squared here, I can go ahead and convert it using the x squared plus y squared. So my final equation is going to be x squared plus y squared plus 3y, that entire quantity squared, is equal to 9 times the quantity x squared plus y squared. If you wanted, you could go ahead and distribute that 9, but I'm not going to mess with that now. All right, let's try one more. This time we're looking at r squared is equal to the sine of 2 theta. Our last one here, we have r squared is equal to the sine of 2 theta. So looking back up at our conversions up here, we have an r squared in our equation, so I could automatically convert it to x squared plus y squared. But I don't have anything related to sine of 2 theta. I do know sine theta, but not 2 theta. So how do I change sine of 2 theta to just a sine of theta? Well, that means we're going to have to use a double angle identity. So I have the equation r squared is equal to, what's the double angle identity for sine of 2 theta? If you don't remember it, you can look up on an identity sheet somewhere. But sine of 2 theta is equal to 2 sine of theta times cosine theta. Okay, so using our identity, we now have the equation r squared is equal to 2 sine of theta cosine theta. Now, with sine and cosine, we need an r. So that means I need an r here and an r with the cosine. One for the sine, one for the cosine. So that means I need to multiply both sides by an r twice. So that really means I need to multiply both sides of this equation by an r squared. Okay, so on the left side, r squared times r squared. I'll just write that as r squared times r squared. On the right side, when I multiply r squared, remember again, r squared is just r times r. And when everything on the right side is multiplied, and remember, order of multiplication doesn't matter. So I can take these two r's and put one with the sine and one with the cosine. So 2 r sine theta, r cosine theta. So my equation is r squared times r squared is equal to 2 r sine theta times r cosine theta. And everything, all the little pieces in here are ready to be converted into rectangular. So I know r squared is x squared plus y squared, but I have to do that twice, right? Because I have r squared times r squared. So x squared plus y squared times x squared plus y squared. And that is going to equal a 2y and an x, so 2yx. We could simplify this a little bit. We could go ahead and FOIL out these parentheses, or we could just write them together since they're the same thing. I could say x squared plus y squared, quantity squared, is equal to 2yx. Again, we could FOIL that out, kind of move terms around, set it equal to 0. For now, though, I'm just going to say that's good enough, and we'll leave it there.